Welcome back. In part 1, we covered the security risks of RAG and how Zscaler AI Guard neutralizes them. Today, in part 2, we're getting hands-on. Join me as we build a RAG pipeline from scratch and apply our AI guardrails. Let's dive in. Here is our ingest and index pipeline. We load the enterprise source documents, pass them through a chunk processor to break them down into digestible pieces. Next, we need to make this text searchable. We run those chunks through an embedding model to turn them into a dense vector. Finally, we store them in a vector database for semantic retrieval. Our knowledge base is now ready. The user prompt goes to LiteLLM, which acts as a proxy before orchestration. It hits our first line of defense, which is Zscaler Precall AI Guardrails. Violations are blocked immediately, and the response is sent to the user explaining why the request was rejected. Clean prompt proceeds to RAG Orchestrator. The orchestrator queries the retriever, which dives into the vector database. Relevant context is derived. This enriched package, clean prompt and context, then goes to our local LLM, which is running Llama in our demo. Next, Llama calls LiteLLM, which triggers the Zscaler output guardrails that acts as an egress filter, checking for data leaks or hallucination. Violations are blocked and an error returned to the user. Otherwise, the safe responses are delivered. Acme Healthcare launched a RAG-powered portal. Here is the data RAG will ingest. We are using Llama 3.2 with large embedding model. We successfully ingested 9 chunks, each 700 character long, with 120 character overlap to preserve context. They are stored in a persistent Chroma database for semantic search. We'll now move through a series of prompts to see how Zscaler AI Guard secures our RAG pipeline. Bob logs in to Acme Healthcare Medical Patient Portal. Here's the first prompt with Bob asking for urgent healthcare copay. Since it's a legitimate request, the RAG system retrieves relevant information and generates helpful response. Bob now issues another query. Since the logged-in user does not have permission to access this protected health information, the request is denied. Next, Bob submits a prompt containing a social security number. Zscaler AI Guard detects the sensitive information and blocks the request before it is processed. Finally, Bob seeks legal advice. This violates enterprise policy, so AI Guard blocks the request and returns a policy-based message. Let's verify the AI Guard logs. For the safe request, both prompt and response are allowed. Attempt to access medical record, sharing of sensitive data, and legal advice requests are blocked by prompt injection, PII deep scan, and legal advice detectors respectively to protect our RAG pipeline. And that brings us to the end of this 2-part series on building a secure RAG pipeline with Zscaler AI Guard. In part 1, we defined the enterprise AI gap and challenges. Then we broke down the RAG stages and security risk, showing how Zscaler AI Guard protects each step. In part 2, we mapped the exact architecture needed to secure our ingest, index, and query flows. Finally, our live demo proved how Zscaler AI Guard actively blocks prompt injection, PII leak, and unauthorized legal advice request. Secure RAG architecture lets you innovate fast while staying safe. Thanks for joining. If you enjoyed the series, please like and subscribe for more deep dives. Let's build a secure AI feature together.